Have you ever looked at a puzzle and felt a pull, a need to figure it out? Maybe it was a tricky riddle, a video game level, or just a question you couldn't get out of your head. In the world of mathematics, some puzzles are so famous for being difficult that they become legends. These aren't your everyday homework problems. They are questions that have stumped the greatest minds for hundreds of years. The challenge itself is what makes them so special. They represent mountains that mathematicians feel compelled to climb, not just for the prize at the top, but for the thrill of the ascent and the new discoveries made along the way. What makes a math problem truly hard? It's usually not about complicated calculations or needing a supercomputer. Instead, the hardest problems often have very simple-sounding questions. You can explain them to a middle school student, and they will understand what is being asked. The difficulty lies in proving that the answer is true for every single number, forever and ever. Let's talk about one of the most famous of these hard problems. It's called Fermat's last theorem. The story begins over 350 years ago with a French lawyer and amateur mathematician named Pierre de Fermat. He loved to read about math, especially the work of ancient Greek mathematicians. One day, while reading a book, he scribbled a little note in the margin. This note would become one of the most tantalizing puzzles in the history of the world. It was a simple idea, but one that would challenge brilliant people for more than 3 centuries. It all starts with a very famous equation that you might already know from school, the Pythagorean theorem. You remember, a squared plus b squared equals c squared. This equation works for right-angled triangles. For example, if you have a triangle with sides of length 3 and 4, the longest side, or the hypotenuse, will be 5. That's because 3 times 3, which is 9, plus 4 times 4, which is 16, equals 25. And what is the square root of 25? It's 5. Fermat thought about this equation and asked a simple question. What if we change the exponent? Instead of using squares, which is the power of 2, what if we used cubes, the power of 3? His conclusion, which he wrote in that famous note, was that it was impossible. He stated that for any whole number n greater than 2, the equation x to the n plus I to the n equals z to the n has no whole number solutions. For generations, mathematicians tried to crack Fermat's puzzle. It was like a siren's call, attracting some of the greatest minds in history. Many thought they had solved it, only to find a small mistake in their logic. The problem became a sort of mathematical graveyard, filled with the ghosts of failed attempts. Imagine trying to build a bridge across a massive canyon. The first builders might only get a few feet from the edge before their structure collapses. The next generation learns from those mistakes and gets a little further. Over time, new tools and new types of materials are invented, making the task more feasible. This is exactly what happened with Fermat's last theorem. The breakthrough came from a completely unexpected direction. In the 20th century, 2 Japanese mathematicians, Yutaka Taniyama and Goro Shimura, were working on something that seemed totally unrelated. They proposed a radical idea connecting 2 different areas of math elliptic curves and modular forms. This idea, known as the Taniyama-Shimura conjecture, was a beautiful and profound concept in its own right. At the time, no one realized it held the secret key to unlocking Fermat's ancient puzzle. The final chapter of this story belongs to a mathematician named Andrew Wiles. When he was just 10 years old, he discovered Fermat's last theorem in a local library book and dreamed of being the one to solve it. After the connection to the Taniyama-Shimura conjecture was made, Wiles decided to dedicate himself to the problem. For 7 years, he worked in secret in his attic, telling almost no one what he was doing. In 1993, he finally announced to the world that he had a proof. The mathematical community was electrified. But the story took another dramatic turn. During the review process, a tiny but crucial gap was found in his reasoning. The proof was incomplete. But Andrew Wiles did not give up. Instead of admitting defeat, he went back to work, this time with the help of one of his former students, Richard Taylor. Then, one morning, in a flash of insight, a moment of pure creative brilliance, Wiles saw the solution. The missing piece clicked into place. In 1995, the final correct proof was published. After more than 350 years, Fermat's last theorem was finally proven. The journey to solve Fermat's last theorem teaches us something profound about the nature of problem solving. It shows us that the most difficult challenges are rarely conquered in a straight line. The path is often filled with mistakes, dead ends, and moments of despair. But every failed attempt is a lesson learned, a stepping stone for those who come next. Furthermore, this story highlights the incredible power of creativity in fields that we often think of as purely logical. The final breakthrough didn't come from a computer crunching numbers. It came from a human mind making an unexpected connection between two seemingly unrelated worlds of thought. This teaches us that whether you are an artist, a scientist, or a mathematician, the ability to see things differently, to think outside the box, is your most powerful tool. The quest for a solution also shows us that some goals are worth pursuing simply because they are beautiful and challenging. No one who worked on Fermat's last theorem was doing it for fame or fortune. They were driven by a deep love for the elegance of mathematics and the desire to know. They were motivated by curiosity, the most fundamental human drive. So the next time you face a problem that seems impossible, whether it's in a math class, at your job, or in your life, remember the story of Fermat's last theorem. Remember that it took over 3 centuries, countless failures, and a global community of thinkers to solve one little note in a book. It's a powerful reminder that with patience, creativity, and the courage to not give up, even the hardest questions can be answered. The journey might be long, but the joy of finding the solution, of finally understanding, is one of the greatest feelings we can experience.